Now in this video, let's look at the mappings possible in a function. So let's look at functions mappings. So we know that if function f is from a to b, okay, then if this is your set A and this is your set B, and for any element of A, there's going to be exactly one exactly one image, exactly every element is uniquely mapped. So from any element, there's exactly one that will go out of it, in this representation. Now, they may, let's say this goes to one element of B. Now, all these lines may go to different elements of B. So from A perspective, what is the case? From A perspective, from every element, there will be one map. It will be mapped to exactly one element. So there will be one edge that is coming out from every element, from his perspective. Now many of these edges, they may go to different elements of B, or some of these edges may go to the same element. Right? Some of these edges may go to same element. So what is this type of mapping? This type of mapping is called many to one mapping. Many to one from A to B. So from A to B, it is many to one. Like why it is called many to one? Because as you can see, if this is, let's say, this is A1, A2, A3, A4, A5. This is B1, B2, B3. Then many elements of A, that is A3, A4 and A5, many elements of A is mapped to one element of B. That is why it is called many to one. Okay, but let's say if I take a subset of A, let's say any other set S, which is a subset of A, okay, that has elements A1, A2 and A3 only. So let's say F is from, it is just, and how they are uniquely mapped? By rule F only, but the set is S to B, and S has only A1, A2, A3. A1, A2, A3. And this is your B, this is your A. Now, this is B1, this is B2, this is B3. Now, what would be the mapping if the rule is F only? So A1 is mapped to B1, A2 is mapped to B2, and A3 is mapped to B3. This type of mapping of a function is called one-to-one mapping. Okay. In this case, every element of A is mapped to, this is S. Okay. In this case, every element of S is mapped to a different element of B. So this is called one-to-one. One-to-one. So one-to-one means every element in domain is mapped to different elements in codomain. Different elements in codomain. We have seen about what is a relation and what is inverse of a relation. Okay, inverse of a relation is nothing but when the elements of B become the first element in the ordered pair. So if F is from A to B, I'm talking, this is a function, but if any relation is R is from A to B, then R inverse is from B to A. Right? We know that. And R inverse is from B to A, and the ordered pairs of R inverse is you just have to swap the positions of the ordered pairs of R, and you get the inverse of the relation. Now, if I ask you that what is the inverse of a function, then inverse of a function uh, is not always possible. For example, consider a many to one function. If I ask you what is the inverse, then if it is many to one, you will find an element in B that has more than one pre-image. In a function f, B3 has more than one pre-image. So when you try to find out f inverse, then in that f inverse, you will have B3 and A3, B3 and A4. So more than one image of B3, this is no longer a function. Function has a function. In functions, the domain is uniquely mapped. So in for many to one function, what we say is that the inverse does not exist. In other words, this is how I have understood. I understand it this way, that if you try to find inverse, you will get a relation but not a function. Okay, but when we are just looking at functions as a topic, exclusively just a function, then we don't say that inverse is not a function but it's a relation. We generally talk whether inverse exists or not. So because the inverse will have multiple image for a given element, we say that the inverse is not a function, so inverse does not exist. Okay, many to one function is not invertible. In this case, if you try to find the inverse, what will be f inverse? So f inverse is from B to S, and f inverse is equal to B1 A1, B2 A2, and B3 A3. Okay, so f inverse exists for this one-to-one function. Let me tell you that f for a inverse to exist, it has to be one-to-one, but not only one-to-one. In this case, your codomain is your range. In functions, I don't know if I have talked about what is range or domain. Domain is your set A, and codomain is your set B. Domain is your set A, codomain is your set B. Okay, and those one function are invertible, which is also onto functions. What is onto function? Okay, so far you know what is many to one, what is one to one. Now let me tell you that a rule is from set A to set B. F is a mapping from set A to set B. Set A is called domain, set B is called codomain. Okay, so from set A, each and every element is uniquely mapped in a function. And when it comes to set B, what how can you look at any element of set B? Means what is the possibilities of any element of set B? Either it is mapped or it is not mapped. If it is mapped, it may be mapped to single element, it may be mapped to many elements, or there may be some elements that do not have any pre-image. It is possible. Let's say if it is not B, let's say when we are talking about B dash is another set, and it has other B4 and B5 elements also. Now, if you look at B dash, then what you will say is that in this case, not all the elements have a pre-image. Okay, so B dash is codomain, and what is range of a function? Range of a function is those elements of codomain that has a pre-image. That is called range. Based on the range, you have two types of functions: onto function and into function. If all the elements have pre-image, then range is equal to codomain. Or maybe some of the elements do not have pre-image, like B4 and B5. Look at this: B1, B2, B3. For this set B, all of them have a pre-image. So the codomain is also the range. Range is also the codomain. Range is equal to codomain. Here, your range is a subset of codomain. So your range is always going to be your range. Range is always going to be a subset of codomain. Okay. If range is when range is equal to codomain, we call it as onto function, and into is when range is a proper subset of codomain. Means that you will find some element that do not have any pre-image. Now let's say f is from f to f b dash, f to b dash. Now you have b4 here and b5 here. Now does inverse exist? Now inverse do not exist. Why? Because when you try to find f inverse, you will get b1 a1, b2 a2, b3 a3. So the images that you are getting, this is one to one map, no doubt. But for b4 b5 there is no image. But the definition of function requires every element to be uniquely mapped. So only functions which are 1 1 and onto, they are invertible. This function is not invertible. So only 1 1 and onto 1 1 and onto functions are invertible. Only 1 1 and onto functions are invertible. 1 1 and onto functions, those functions which are 1 1 and onto, they are called bijection. Means 1 1 and onto together. When any function is 1 1 also and onto functions, those functions we call it as bijection. Bijection. And so only bijections are invertible. Bijective functions are only bijective functions are invertible. Okay. So these are different mappings in a function, many to one and one to one. Are there any other possible mappings? No. The reason is very simple, because just look from A. From every element, only one edge can come out, right? Only one edge can come out. Now these edges may go to different elements. All these edges may go to different elements. Okay, then it will become one to one. Or maybe some of the edges are going to just one element. Maybe some of the edges go to same element. If some of the edges go to same element, then we call it many to one. So there is no other mappings possible. Now this mapping that we are saying many to one, this is from A to B. So from A, many elements of A may be mapped to one element. So if in your mappings there exists some elements, if in your mapping there exists some elements that are mapped to same element, then it is many to one. And if in your mapping all the elements are of S, or all the elements of domain is mapped to different elements of uh, codomain, then it is a one-to-one mapping. So how do you prove if a given function is one-one function or many-one function? How do you prove it? Now for one-one function, if A is not equal to B, if A is not equal to B, then f of A is not equal to f of B. Is this not the case? By the definition of one-one function, for any two different element, if we know that it's two different element, then their image must also be two different elements. So for one-one function, if A is not equal to B, then f of A is not equal to f of B. Right? So how do you prove a function to be a one-one function is, you assume that A and B are two different elements. Okay, you suppose that you take any two arbitrary elements and you assume them to be different. Suppose A not equal to B, and you try to show that f of A is equal to f of B. Then solving this, Solving this will ultimately give you what, that a is equal to b. If this happens, it means what? It means the function is 1 1. What I mean to say is that if you want to prove any given function is 1 1 or not, how do you do it? Let's say if f of x, so polynomial functions, they are 1 1 function. Okay, let's suppose a polynomial of degree 1, y is equal to ax plus b form. Let's say y is equal to 3x plus 5. Now we say that this is 1 1. It is very clear that this is 1 1, and this is also one of the test. If the graph of a function is given, then you can find how, if it is many 1 or 1 1. So it's very easy. Just this is, I will explain it again, but I'm removing this. Okay, if we have to know if it's a function, relation, or function, if it's a relation or function, how do you find it? How do you find if it's a relation or function? This idea of a function where f is a rule, f is a rule by which you map, rule by which elements of domain is mapped to codomain. Elements of domain is mapped to codomain. Okay, input is taken from the set domain, and the output belongs to one of the elements, belongs to any one element of the codomain. Now, we represent y to be equal to f of x. F of x. What does this mean? It means that to your function, your input is x. When your input is x, it is like a machine. When you give some input, it will give some output by applying a rule on this input. Okay, say f is a function from real number to real number such that the mapping is twice the number. Like if f2 is here, then you will get 4 as y. Means when x is 2, then y is 4. This is your input to the function and this is your output to the function. Similarly, when x is 4, then y is 8. Look carefully, I have taken domain to be set of real number and range to be codomain to be set of real numbers. Okay, now what happens is, so what is this rule? You can say that a rule is, your f is an expression with respect to the input variable. Knowing this expression means you know the function. Knowing the expression means you know what the function is. So in this case, you can say that f of x is equal to 2x. So when you know what x is, you use this expression to get the value of y. That's why I have written here y to be equal to f of x. F of x is an expression with respect to the input. Okay, now you know that in relation also we have seen many different representations show the mappings in this manner. One another representation we have seen is that of a Cartesian plane. On x-axis you have elements that come in your as your first ordered pair, or elements of set A on the x-axis. In case of relation, you have elements of set A on x-axis and elements of set B. Means if your relation R is from A to B, then in your Cartesian plane representation, elements of set A is on x-axis, elements of A on x-axis, and elements of B on y-axis, and then any point on that xy plane will represent an ordered pair of your relation R. If let's say if this is some b1 and this is a1, and let's say a1 b1 is a1 b1 belongs to r, you will mark it, you will mark it. But if let's say a1 b2 is not, a1 b2 is not in ordered pair, then you leave it, you leave this position as it is, you don't mark it as. So this is how your relation is plotted on your Cartesian plane. Now in case of function, your domain is on x-axis and your codomain is on y-axis. Function is from a to b, then this a's elements of a, that is the elements of domain, elements of domain on x-axis and elements of codomain on y-axis. This is by convention. Okay, look at here, this is your x-axis. Okay, this is your x-axis and this is your y-axis. This is 1, then this is the mapping is, so this value is nothing but 1 and 2. So this is 2 on your axis. Similarly, this is 2, let's say, then this will be 4. This is 2, then this will be 4. Okay, let's say this is 3, then the corresponding value, this one, is nothing but 6. This is 3 and 6. This is 2 and 4. This point is 2 and 4. Okay, so that's how the graph of a function is. If the graph is given, I mean, look at this, f of x is equal to 2x. This is an expression, 2x, 2x, where x is an input. This is one expression. From this expression, can you guarantee that this is a function? Just from an expression, can you guarantee that this is a function? Of course not. Of course not. In this case only, if you see f is from R to R, let's say if I make R the codomain to be only up to 6, you can't say that this is a point for 4 and 8 is a part of your function, that you give an input 4 and you will get an output 8. No, because your codomain, I am limiting your codomain from 0 to 6 only. So 4, 5, 6, whatever comes after 3, all of them do not have an image, and so this f is equal to 2x is not even a function. If I limit the codomain to be from 0 to 6, then this f is not a function anymore. Just by looking at the graph, you have to know if it is a function or not, because definitely it's a relation. If there is ordered pair, here you have ordered pair, means that it's a relation. But if this relation is a function or not, if you have to guess that, then you know what the definition of a function is, and based on that you can find it out. This is what your function is. Now in this you have two component. Let's say in this you have two component, all elements uniquely mapped. If your codomain is 0 to 6, then from 4 onwards, fx is equal to 2x is not a function, because 4, 5, 6, so on, they are not having any image in it. Okay, one more thing, I've been taking only natural numbers as x, however it is r, but as you can see, uh, even you can take 2.1, then y would be 4.2. okay, you can see it's a continuous graph. So for every element in x, for every point in x, you have an image up to 3, up to 3. If your codomain is 0 to 6, then up to 3 you have. For every point from 0 to 3, from 0 to 3, it is, you will say that it's uniquely mapped. It's uniquely mapped. But from 3 not included, from 3 not included to infinity, it's not mapped. No mapping. No mapping. So it is not a function. So it is not a function. Okay. But if your f is from, but if your f is from R to R, then it is a function clearly, because for every input you are getting a unique output. For every input, if you see 4, then 4, for 4 you get a unique output, that is 8. This is 4 comma 8. For 5 you get a unique output, that is 5 comma 10. So for every element, we have a unique output. So it is a, all elements are uniquely mapped. So it is a f of x is equal to 2x. F of x is equal to 2x, where f is from R to R, is a function. Is a function. If your domain is on the x-axis and you want to look if this point, any point is uniquely mapped or not, how do you find it? How do you find that what is corresponding to, what is y corresponding to x? You are drawing a line that is parallel to your y-axis from that point of x. So for any x, if you want to find its image, you are drawing a line parallel to the y-axis, and wherever it will cut the curve, that will be its image. So when do you say that this curve is that of a function? For all the points in the domain, when you draw a line perpendicular to x-axis from that point, from all, okay, if you draw a line perpendicular to x-axis, for every point of domain, and it cuts the curve, and that perpendicular line cuts the curve at exactly one point, then it's a function. Okay. Now if you find, if there exists any line, any perpendicular line, if there exists any perpendicular line from any point in the domain, that cuts your curve at more than one point, or do not cut the curve, that cuts your curve at more than one point, or do not cut the curve at all, this is not a curve of a function. Of course it's a relation, but it's not a function. Now you know if a curve is given, how to know if it is a function or not. Now then the second thing is, there are two types of function: one function and many one function. Given the curve of a function, how do you determine if it is one or many one? In case of one and many one, look at it from the codomain elements of codomain perspective. Then if you take any element, then what are the possibilities for this element? Either it is the case that if it is one, then it may not have any preimage, or it may have one preimage exactly, but not more than one. So for a one function, every element of a codomain has at most one preimage, right? So for 1 1, every element of codomain has at most one preimage, at most one preimage. Codomain is on your y-axis. So these are every point on your codomain. If for any element you draw a line parallel to the x-axis from that point. So parallel line to x-axis, you get this point. What does this point means? With respect to this point, it means this is your pre-image. If this is your y1, then this is x1 y1 point. This point is x1 y1, then the x1 is the pre-image of y1. So if it is a 1 1 function, then if you draw any line, in this case this is also an onto function because f is from R to R and y is equal to 2x. This is an onto function. So for every element in y also you have a pre-image, that is y by 2. So the test for 1 1 from every point, from every point on codomain, from every point on codomain of y-axis, a line perpendicular to y-axis, or you may say the parallel to x-axis. So from every point, if from every point on codomain of y-axis, a line perpendicular to y-axis cuts the curve at most one point, at most one point, then this is uh, 1 1, then this is 1 1. Okay, test for many one, any one point that cuts it at more than one place. If there exists a point on codomain such that perpendicular line through it, perpendicular line to y-axis through it, through this point, cuts the curve at more than one point, cuts the curve at more than one point, then it's many one, then it is many one. Based on the type of mapping, you have 1 1 function or many one function, but based on your range and codomain, what will be the test for onto and into? For every point of codomain on y-axis, you draw a line parallel, okay, then wherever it cuts the curve, that is your pre-image for that codomain element, right? Now it will be onto if for all points it cuts the curve. If you want to know if it is onto or not, what do you want to show? You want to show that every element of codomain has a pre-image. So for every point, if I have to write it for onto, just for a moment think about this, that this is a test for onto. Then if from every point on codomain of y-axis, a line perpendicular to y-axis cuts the curve, that's it. If it from every point, if it cuts the curve, here I am writing at most one point, so it may not also cut for 1 1, I don't care, but if it is onto, then it must cut the curve. So what will be the case if it is 1 1 and onto? It means that for 1 1 and onto, every point on codomain of y-axis, a line perpendicular to y-axis will cut the curve at exactly one point. For all such points, it will cut at exactly one point. If I am looking to get if it is into or onto, I am just seeing for all such points. If there exists any point, if there exists any point for which it does not cut the curve, it means it is in. Okay, so that's it. Okay, let's take just one example. Is this many one or one? If you take up this y, then it cuts the curve at this point and this point. It means if this is, let's say if this is x1 and this is x2, then this point, and this is, let's say, y1, then this point is x2 y1 and this point is x1 y1. So this is many one. How? Because y1 has two pre-image, so it is like this. Here you have x1 and this is your y1 and this is your x2. X1 is mapped to y1 and x2 is mapped to y1. So this is many. Okay, if all lines parallel to y-axis uh, cuts at exactly one point, then it's a function. Now, okay, to be very precise, okay, I assume that the curve is only up to the domain. So I am assuming that if, let's say, this is your domain, region of domain, I'm just looking up to this area, and then it will perfectly fit, and the definition will perfectly fit. I'm not going to draw any line parallel outside of this domain. Okay, whatever definition I'm writing here, that is very much precise definition. The assumptions is that I am drawing it within the domain, and similarly for horizontal parallel line, the assumption is that I'm drawing that horizontal line within the domain section or domain interval. So if all line parallel to y-axis cuts at exactly one point, then it's a function. Otherwise, it's a relation. Otherwise, relation. It's just a relation. Okay. And how do you find? So I'm erasing again. So given the curve or graph of a function, so it's known that it's a function. It's known that this curve is of that of a function. Then how do you find if it is many one or not? One or many one? One or many one? For one or many one, if all horizontal, if all lines parallel to x-axis, if all lines parallel to x-axis cuts the graph, cuts the curve at most one place. Why I am writing at most? Means I'm trying to define it for one. So why I'm writing at most? Because maybe there are some elements of codomain that do not have any pre-image. It is possible. So at most one place, then it is one. Then it is one. So one means for different elements, different image. Now, if there exists a line, if there exists a line, if there exists a line parallel to x-axis, parallel to x-axis, which cuts the curve at more than one place, which cuts the curve at more than one place, it is many-one. Then it is many-one. Then it is many-one. Now, from range and codomain perspective, if it is onto function or into function, so how can you say if it's onto or into function? So if it is one and onto means what? It means that all the lines will cut at exactly one point. All lines parallel to x-axis. Means if you are taking up any line that is from any codomain, you take up any point in codomain in on y-axis, any point, then it will cut it exactly one point. Meaning to say, I just want for every point, I just want a pre-image. So if all lines parallel to x-axis cuts the curve at exactly one place, then it is 1 1, and only if all the lines parallel to x-axis cuts the curve, then it is many one. Then it is onto. Otherwise, into. Okay, let me give it for onto and into also. Let me do it separately. Onto and into function. So given a curve of a function, if it is onto or into, how do you find? If all lines parallel to x-axis cuts the curve, cuts the curve. So if all lines parallel to x-axis cuts the curve, then onto. If there exists a line, if there exists a line parallel to x-axis, if there exists a line parallel to x-axis that don't cut the curve, that doesn't cut the curve, that doesn't cut the curve, then into. Then into. The video is getting long, so there are other things that I wanted to cover in the same video, but it will be covered in the subsequent videos. So I will continue this function mapping in the next video, and I will describe this in more details with more such with more formulations, and then maybe in the next video, or maybe in the next to next video, we will see that what types of mappings are possible in a relation. Thank you very much.